There is another layer 2 security feature called .1x. .1x is going to provide you a challenge message if you're trying to log into that switch or trying to pass through the switch. Both. Meaning, see, this client, wait a minute, please. Oh, the pen is not coming for me. Right. There's a client server relationship. Meaning you need a special software on the client on the computer. That is very important. And with that software, you need to provide the credentials in order to use the network behind the switch and also to log into this switch itself. We'll not be able to do this lab, but I'll be showing you what to configure on this switch side. We are not going to focus on the client side. Even in the AAA, what I focused is what to do on the switch side. Our aim is not to learn AAA here. Our aim is if AAA is there in your environment, if your security engineer says we have a AAA and this is what the pre-shared key and this is what the IP address of the AAA server, then we should know how to enable on the switch. That's what we learned in the previous class. Similarly, if .1x is needed, what need to be configured on the switch? And you may use this external authentication server like AAA server. So whenever a client tries to get into a network or to the switch is going to send the challenge saying provide me the username and password. When the username and password is given, switch will go to the authentication server, get the approval. If it is approved, the network access will be provided. So that's .1x. .1x is a protocol. And to configure, it's same like AAA new model to enable AAA. For .1x, we need AAA. And then AAA authentication using .1x is a keyword that we should use. And then you may use a local or you can use methods like TechX and Radius. And then this is the command to be enabled globally in order to enable .1x. And then whichever the port that you want .1x, you can go and enable under the port level, interface level. All right, so this is the global, or if you want for specific interface, this command going under the interface. That's all. That brings the .1x authentication up. So if .1x is needed, this is what we have to do. The rest of the things are not our job. Rest of the things, the AAA server, the security engineer is going to take care of it, and the clients need to have a client software to provide the username and password. Those things are not our job. Now, the next thing is the attacks that are based on VLAN. Using VLANs that we have in our switches, people may try to damage us. You see, everyone knows that there is a VLAN called 1 as a default VLAN. And everyone knows that VLAN 1 will be considered as a native VLAN by default. Native. What is native VLAN? When a packet comes to a trunk port untagged, when a packet comes to a trunk port untagged, when a frame comes to the trunk port untagged, meaning without any VLAN ID, that packet will be considered as a member of the VLAN number that you define it as native. By default, because we don't have any other VLAN other than VLAN 1, because we don't have any other VLAN. When you take the switch first time, you see VLAN 1. So VLAN 1 itself will be configured by default as a native VLAN. So if any traffic comes untagged, the trunk port will accept the packet as a member of as a as the member of VLAN 1, as a member of broadcast domain called VLAN 1. That is native VLAN. So every good people and bad people in the internet knows that there is a VLAN called 1, which is a default VLAN. Also, it is a native VLAN. This may be opening gates for the attackers. How? If I use VLAN 1 for some important department, then there are chances that the attacker may do something in that VLAN. So better not to use VLAN 1. Or put all the ports, the unused ports, in this VLAN called VLAN 1, because VLAN 1 is not going to be used by us. We are not going to use it. VLAN 1, we are not going to use it. Unused VLAN, or you can define, let's say VLAN 333, something like that, and put all the interface in that VLAN. That is more good than using VLAN 1. Better not to use VLAN 1 for any reason. Use only some VLANs that you define as VLAN for production as well as for unused. Likewise, we are going to see a lot of suggestions in this chapter. We're going to discuss on few VLAN based attacks and how to protect against those VLAN based attacks. See, again, there is no security engineer on earth who can protect your network 100% guaranteed protection. No one can give, because every day there are new way of attacks coming in, because basically you got only 7 layers in OSI. If someone is a master of that 7 layer, they know all the loopholes, so they can easily cause damage. So it's not that difficult to attack a network, because it's just 7 layers you got and some encryption algorithm you got. So if you don't have those encryption algorithm, if you don't put those necessary mitigation commands, you cannot protect our network. Even after doing all this, still you cannot guarantee security. So what you are going to see in this presentation is very little of many attacks. Yeah? So let's see some of the attacks. Here we are going to understand what is VLAN hopping. What is VLAN hopping? Attacking systems spoofs itself as a legitimate trunk negotiating device. Meaning, see, there is a computer at the bottom which is written as attacker. That device is pretending to be a switch. A switch only can negotiate trunk. So this attacker computer is not a real switch, it's a computer. But it negotiates dot on queue. It negotiates trunk. Now, if you leave those unused ports in the switch in a up state, see on all switches in Cisco, the ports are up. Only on routers the ports are down. We used to say no shutdown. All the ports are in upstate, and you thought, okay, we are not using that port. Uh, so you did not enter into the unused ports and shut down that port. Because we have not shut down the port, and because we have not done any configuration on those unused ports, by default the unused ports will be in dynamic auto. Because it was in a dynamic auto and in an upstate, the port was in upstate and dynamic auto, this attacker managed to form trunk. So attacking device gains access to all VLANs and the data in those devices that are in all VLANs. See, very simple. Sitting in a computer, he can see all your VLANs. Sorry. And now what he can do, if he can negotiate trunk, he can also generate packets with some VLAN ID. Let's say he want to talk to the workstation, then he puts some packet in VLAN 10 and send it to workstation, which is on VLAN 10. If he wants to talk to the server, he generates traffic with VLAN 20 and send it over the trunk link, which he negotiated, and now he gains access to the server. This is what called as VLAN hopping attack. So the attacker is not even using a switch to do this, just software running on his computer can do this. So he can now have visibility to all VLANs in your network. He can jump between one VLAN and the other and see the data inside all those computers in those VLANs with some other special tools. So you already know the solution how to prevent this. Simple. Put all the unused ports in a shutdown state and also assign it to a unused VLANs and make it as an access port. Don't leave it as dynamic auto. Don't leave any port in dynamic auto. Very good practice. Second, put those unused ports in unused VLAN. Also keep it in a shutdown state. Problem solved. See, this is again another example. Double tagging. So for this also attacker needs special software. Because the attacker has already negotiated trunk here, he can send a tagged traffic, but this time he is doing double tagging. Double dot one queue header. One header says this packet wants to go to 10. So when the packet is received on switch 2, so the switch, let me call it the switch A. Switch A considers the packet as a member of VLAN 10 and send it to VLAN 10. And the inner header says it belongs to 20, so it is also sent to VLAN 20. So now attacker has got access to both the VLANs. The same this data that attacker trying to put is going to both VLAN 10 member as well as VLAN 20 member. Double tagging allows the frame to be forwarded to destination VLAN other than the source VLAN. So this attacker, he says he is coming from VLAN 10 and he gained access to VLAN 10 and it is also now delivered to another VLAN which is not the real source. These are all attacks. This is not normal. To prevent this, all that you need to do is configure the port as an access port so that the attacker will not get trunk privilege. Attacker cannot form trunk. So switchboard mode access, switchboard access VLAN. Give some unused VLAN number. Also, additionally, if possible, shut the interface down. That is better. Shut the interface down. Anyhow, if you want the port to be used, you will be logging into the port and assigning to some useful VLAN. That time you can say unshut. No shut. So we learned what is VLAN hopping attack, and we saw what is double tagging attack, and we saw how to mitigate. It's not a big deal. Take it as an access port and assign the access port to unused VLAN. Additionally, if you can shut the interface down. The next is VLAN ACL or MAC ACL or Layer 2 ACL. All right. So far, good. The topic that we covered. Any
Yes, sir.
question on
Okay.
double tagging? VLAN
No,
hopping attack.
I'm clear with that.
Okay, this is same like your layer 3 ACL, same like layer 3 routed ACL. But here the additional thing is you can match with MAC address, you can match with IP address as well as the VLAN ID. You see, you can match with IP address, you can match with MAC address, you can match with VLAN number. Whereas we go and apply to a VLAN list. So an action can be a drop action or forward action or redirect. So this is how we create an access map for VLAN and we specify what to match. Even the IP address can be matched, even though it is a layer 2. You can call a layer 3 access list here. And then optionally you can include MAC address. You can take actions and then apply it to a VLAN. This is how we applied VLAN filter. And the name, let's say you have given a name as drop or something, call the drop here, and then you can say this is for VLAN 10 or VLAN 100. So this is how we can do layer 2 access list, VLAN access list. This I don't see many using it, but this is also one of the access lists that we got. I tried doing this in multi-layer switch, it works. For that you need EVE. Right, so that is about MAC ACL. Let me repeat the steps again. You create an access map, and then we call a layer 3 access list, or you can call a MAC access list. You can also have a MAC access list where you have the source and destination MAC address. Anyone, you call any one of this, and then take action. What to do? Drop or forward. That's the mostly used actions. And then you need to say for which VLAN you are writing this in this statement. That's all. Right? Later, if in this class or next class, we'll do this lab. Do you have
I
any
think I
question
haven't
on?
haven't seen that in, and yeah, I think they
Yeah,
don't use it
they
much
don't
in. I
use it.
haven't seen it in the enterprise environment.
Yes, that's true. But it works. We can do it
Okay.
if you need. You can have this also. Why in production they don't want to use it is because sometimes the device we keep swapping, the MAC address keeps changing for the devices in our organization. Then you need to go again and change the access lists, matching
Yeah.
with the new MAC addresses, which is a little bit tough. Copying MAC address without mistake, typo errors. So I don't see many using this. Now our next topic is private VLAN. There's a connection between this private VLAN and VTP. If you will have version 1 and version 2 VTP, you cannot have private VLAN. VTP version 1 and 2 does not propagate private VLAN configuration. You must configure private VLAN on each device when you want private VLAN ports. In VTP version 3, VTP does propagate private VLAN configuration automatically. Wonderful. So, if you are going for private VLAN and VTP, and you want VTP to propagate the private VLAN, see, usually we enable VTP in order to propagate VLAN. In order to propagate VLAN, we enable VTP. But when you have private VLAN, don't expect the propagation if you got VTP version 1 or 2. VTP 1 and 2 is not going to propagate. VTP 1 and 2 will not propagate private VLAN. Only version 3 will propagate. That is what I was saying. Private VLAN and VTP has got a connection. Version 3 is mandatory if you are expecting VTP to propagate everything proper. See, when I have private VLAN, if VTP is not going to propagate it, then there is no use of that VTP. What is the job of VTP? To propagate VLAN. But when I have private VLAN, VTP is not ready to propagate. Then why I need VTP? So if you are using private VLAN, make sure you enable version 3 VTP. Only then you will get the propagation of VLANs to the satisfaction. Now, what is private VLAN? Before I get into private VLAN, I would like to ask a question. Is it possible for members of same VLAN to deny access? Members of same VLAN, which are in same subnet, can you deny them from talking? It's a question I'm asking. Can I see there are 5 computers in VLAN 100, and I do not want these 5 computers to communicate each other. See, they are in the same subnet, so there is no layer 3 issue. They are in same VLAN, which means they are in same broadcast domain. They are in same broadcast domain, but I do not want them to talk each other. It's against the law, no? It's against the normal behavior, isn't it?
Yeah.
Members of same broadcast domain should communicate. That's what we learned. All the members of same VLAN will communicate by default. But let's take one example. You got a browsing center. You know browsing center, no? Because every country have got different term to say. Browsing center, net cafe, a lot of things they say. Okay, let's say browsing center. You know browsing center. And where we go and use internet, like a public telephone booth. So we got the browsing center with, let's say, 20 seats for customers to use their computers, internet, rental. You got 20 seats. So for all the customers, let's say you have given VLAN 100. For customers, VLAN 100. For the management of the browsing center, you gave VLAN 200. Now, customers cannot enter into management's domain because they are in 2 different broadcast domain, isn't it? Management is in 200, customers are in 100. So customer cannot enter into management's VLAN Why? The router won't allow. If they want to enter, they need to go through the router, and router will have an access list, isn't it? Router will
Yeah.
not allow the customers to log in to provider, so to the administrators of the browsing center. But the administrator will have a privilege because the router permits. They will have permission for inter-VLAN routing if the traffic is generated from the administrator side, then the customer computer should respond. But customer cannot initiate any conversation to the administrator. So this firewall, this feature, this policy will be applied. As a result, this 20 customer who is using the computers will not be able to enter into administrator's computer. But administrator can easily get into all customer and see what they are doing. Of course, they can see.
Yeah.
Now, this 20 customer, they can also see each other because they're all in same VLAN,
VLAN.
which is not really an acceptable one. It's like, I'm using my cell phone publicly. It's like me sharing my cell phone uh, with everyone. Openly, I'm using my cell phone, which is not really okay. No one will like it. How can we allow the other 19 people to see what I am doing in my cabin in the browsing center? So how you prevent it? You cannot provide each customer a VLAN. That won't be that good. If you want, you can do it, but usually customers one VLAN, administrator another VLAN. That is how we do. See, with the help of this private VLAN, that's why it is called as private VLAN. You can make the members of same VLAN not to talk. See, that's why they have named it as private VLAN. Members of same VLAN usually communicate, but here they don't communicate. There are three modes in private VLAN. One is Prometheus mode. So it is written in the page, top right, top. Prometheus port.
Promiscuous mode. Yeah.
The other two are down, you see, secondary, isolate in the bracket, isolate and community. These are the three different modes. These are the three different modes a port can be assigned in private VLAN. If you assign a port as Prometheus port, that Prometheus port can talk to all members of isolate and all members of community. But when you assign a port as a member of community, that member can only communicate to all other members of same community VLAN and also with the Prometheus. So community can talk to Prometheus. Community can talk to the members of the same community. Community cannot talk to other community members. See, for example, here 201 is the VLAN given for community. So members of 201, wherever they are, whatever the switches they are in, no problem, they will be able to communicate because they are members of 201. If there is another community, let's say 301, that 301 cannot talk to this 201 because that is a member of another community. This 301 and 201 has got one common friend, who is that? Prometheus. And Prometheus will take the traffic to router if you want to communicate from one community to another community. In router, we will have an access list whether to allow them communicate or not. We don't want to communicate. We don't want to allow them communicate. That is why we have put them in different community. So members of same community will communicate, or also the community members will communicate to Prometheus. Next, members of isolate VLAN. Here it is 200. Members of isolate VLAN, as the word says isolated, they are not going to talk each other even though they are member of VLAN 200. They are member of VLAN 200, but they are not going to talk each other. They will not talk each other because they are member of 200. 200 is defined as isolated. But all these members of isolated can communicate to Prometheus. They can communicate to Prometheus. They can talk to Prometheus. So if any isolate member wants to talk to any of the community member or any of the other isolate member, they need to come to the Prometheus port, and Prometheus port only need to allow. Otherwise they cannot communicate. See, in first place, we do not want all the customers of the browsing center to communicate. That's why we have put it in the community, sorry, in a mode called isolated. Yeah. So this 200 VLAN and 201 VLAN, they are not the primary VLAN. Let's say there is a VLAN called 100. 100 is the VLAN of the Prometheus port. That is the primary VLAN. You see the blue line? Blue line is coming from Prometheus port. Prometheus port is the trunk port that connects to the router. See the blue line? Blue line belongs to Prometheus port. It can talk to isolate, it can talk to community. Yep, Prometheus has got access to everyone. But if you see the secondary VLANs like red VLAN is isolate VLAN, which is 200. Yellow is community VLAN, so members of same community can communicate. They can also talk to Prometheus, but they cannot talk to red because red is an isolate. Members of isolate, even though they are members of same VLAN, they will not be able to communicate, but they can talk to Prometheus. And if these two isolate wants to talk, they need to go through the Prometheus. So there is a primary VLAN called VLAN, let's say 100. That's a Prometheus VLAN. And these are all secondary VLANs, 200, 201. You see. You can also call it a sub VLANs. Right. So, do you understand the story of private VLAN?
Yes, sir. So basically, is with community VLANs, the same community devices on the same community can talk to each other, and if it is a different community, they have to go through the promiscuous port
And get routed through the router.
to the
See,
router.
for example,
So in this case, yeah.
sorry to interrupt you. For example, you see, there is another VLAN 301, which is community. These two can talk each other, though they are in different switch. But if this alpha wants to talk to this beta, they are not in same VLAN, but they are coming under the same primary VLAN. So this is another third one, which is 301. And this community is 201. So all that they need to do is they need to go to Prometheus, and Prometheus will route them to the router, and router will route from one broadcast domain to another. It's same like inter-VLAN routing. Members of different community will of course will be in different subnet. Different subnet, you need different broadcast domain controller which is in the router. So with the help of router only they will be able to communicate. Members of same community can interact. Members of different community, only when router permits, only when Prometheus allows, it is possible, otherwise no. First of all, we do not want them to communicate, that's why we have put them in different community. A very rare case, if you want them to communicate, then you need to allow writing policy in the router, access list in the router. According to layer 2, they don't communicate. They need layer 3's help.
Layer 3, okay.
Same, between the isolate members, if they want to communicate, they need, again, even though they are in same VLAN, you will be applying different subnets for each customer, maybe /32 host, and get routed through the router. Not 32, sorry, not 32, at least 26, 28, something like that. Okay, so members of same isolate VLAN will not communicate. We do not want them to communicate. That's why we have put them in isolate. Very rare case, if you want to allow them to communicate, make sure they are all in different network, so that through layer 3 they can communicate. Layer 2 they don't allow because they are in isolate member. They got isolate membership. Alright, this is a Cisco's concept. You will not see this private VLAN anywhere applied in the real world. It's supported only in Cisco device, and even Cisco guys don't use it. But it's really a fun to configure this. It's really a nice thing to configure and see how it works. But unfortunately, we don't use in production. The reason is, in production, you don't have only Cisco. You got multi-vendor switches. That's why we don't use VTP. That's why we don't use this private VLAN. Both are Cisco proprietary. All right, the configuration is looking like a little complicated, but it is not complicated. It is not complicated if you understand the logic. You see, as I said, VLAN 100, let's say primary, VLAN 200, VLAN 201. A secondary VLANs, in which 200 is isolate, 201 is community. So here, whatever I have written, you need to put them in commands. So we need to associate this 200 and 101, so 201, we need to associate to this. And this need to be the VLAN on Prometheus port. That membership needed to be done. For example, if I will go to this port, this is a port where I'm going to configure VLAN 200. I need to say, hey 200, you are a part of 100. You are 200, no doubt, you are an isolate port, but you are under the primary VLAN 100. Likewise, when I go to this community port, how will I configure? I'll say you are a member of 201, but you are not the hero, you are coming under Mr. 100. This mapping, this association, associating the secondary to the primary need to be done, associating this, mapping this isolate to the primary on the interface need to be done. This is global, this is interface level mapping. If you understand this, then configuration is going to be easier, right? I'm going to explain you the steps, and
Yeah.
definitely it will be easy for you to get it. Though we are not doing, you will still be able to understand. As I said already, there are three different type of port types in private VLAN. Isolate, they can only talk to Prometheus port. Prometheus, they talk to all ports. Community, they talk within the member of the community as well as to the Prometheus port, all Prometheus port. Means if VLAN 100 is the Prometheus VLAN, the primary VLAN, wherever VLAN 100 is, this community can talk. So Prometheus port need not to be one port, it may be more than one. Now, this is not the place you need to start. You need to go back one step and then start from. Okay, correct. This is right. No, we say what we do is first we say private VLAN. First, we need to say VLAN 100, and you will be inside the VLAN mode. Yeah, you'll be
Yeah.
inside VLAN 100. Now you need to say whether this is a primary VLAN or not. Yes, for us it's primary VLAN. And then go out and say 200. Then we'll say isolate. That's what according to our diagram. And then again you go out of this mode. Then you say 201 and then you say community. After you create all these three VLANs with the role as primary, isolate, and community, after that come again inside VLAN 100, which is primary. Come again inside under VLAN 100 and say this command: private VLAN associate. You're already inside 100, you're going to associate 200 and 201. See, associating the secondary VLANs with the primary VLAN. If you have mistakenly added some VLANs as secondary, you can use this command remove. If you have already added, then you can use another VLAN to add this command, add VLAN. Add secondary VLAN, SVLAN is secondary VLAN. So this association is important first. First we need to say which is going to be primary and which all are under this primary. This association is important. After which you can verify this by typing show VLAN private VLAN. That will show what you have configured. You have configured 100 as primary and then 200 as isolate secondary, 201 as isolate secondary. All right, is there any question in this page?
So when we start the configuration, so let's say VLAN 100 is the primary, so we say VLAN 100 and then private VLAN. That's the steps, isn't it? And then the next one is the VLAN 200 and
VLAN
then isolated
100 primary, private VLAN primary.
primary. Okay,
And
yeah.
then VLAN 200 private VLAN secondary. Sorry, isolate,
Okay.
isolate.
Isolated.
And then 201 private VLAN community. Those three steps you need to do. After which you come back again and type VLAN 100 and say private VLAN association command to associate all those isolate and community VLAN to the Prometheus. To associate the secondary VLAN to the primary.
Yeah.
Is this page clear?
Yeah. Yeah. It's clear.
Now, so far what we have done is only on the global mode, isn't it? Nothing on the
Yeah.
interface side. Now, on the interface level, we go and say switch port mode private VLAN. If it is Prometheus, you say Prometheus port, meaning if the port is not a member of isolate or community, if the port is a member of primary VLAN, then you need to say switch port mode private VLAN Prometheus. If it is a member of isolate or community, in another word, if it is a member, if this interface is a member of the secondary VLAN, then you need to put this keyword host, right? If it is Prometheus port, if it is this port, then we say switch port private VLAN, switch port mode private VLAN Prometheus. For all other ports, you will say switch port private VLAN host.
Host. Yeah.
Now, if it is host port, then you need to also continue saying this command. Switch port private VLAN host association First you say the primary VLAN number. What is the number? 100
100.
followed by 200 if it is
200.
isolated.
Okay.
If it is community, you will say 201. Isn't it? Got it?
Yeah. Yeah.
So this command is what? Going to be on the host port, secondary ports, isolate and community ports. Now on the primary port, the Prometheus port, you should not use the keyword host association because it's a Prometheus port. We have said switch port mode private VLAN Prometheus. Under that, after this command on the Prometheus port, we go to this command. We say private VLAN mapping. Earlier in the global mode, we said association. Now you are using mapping 100, 200, 201. Both are needed. Globally also you need to associate. And the interface also we need to say this interface is a Prometheus port which will respond to, which will communicate to both 200 and 201. Is there a logic here? Yes,
Yeah.
there's a
Yeah.
logic. That's all. We need to verify. Show interface private VLAN mapping. You will see all the mappings. That's all. That's all. Private VLAN is only this much. Now you did this in one switch. If you want this to be distributed to all other switches, not the interface configuration. Interface configuration we have to do manually on all switches. The previous page, this page, whatever you did in this page on one switch,
Yeah.
if you want that to be propagated to other switches, you need VTP version 3 so that you no need to repeat these things. Only on the interface you need to do those host associations and mapping. But again, I'm telling you, though it is very interesting topic, we don't use in production because it's Cisco's only. Sorry. Next chapter is about spoofing attack. Spoofing means fooling, pretending or fooling someone something else other than what it is. That is spoofing. So spoofing can be done wherever open discovery happens. Like ARP does an open discovery asking, hey, is there anyone called 10 0010? Will you please give me your MAC? That's open request send without any condition to anyone who receives it as a layer to broadcast. So whenever there is a flooding of requests, whenever someone sends a request as a flooding, as broadcast without knowing to whom to ask, wherever there is a discovery process, either using broadcast or sometimes even using multicast, there are chances of spoofing. I still remember when I was a small boy, maybe like 7 or 8 years old, that much only. I was a very hard worker from my childhood, and there was a song competition in our church, and I did very well. I answered all the questions, but the teacher was partial. She gave name of another student who really did not perform well, but who was sitting always close to the teacher.
Okay.
Maybe relative or maybe belong to her region. So people from various regions gathered there in Chennai in one place in a church meeting, and there was a separate place for children. A lot of children competition, like in song competition, I did very well. But this teacher gave prize to someone else. It means name of some other
Okay.
person. And I did not expect that. When every names were called, I was expecting, okay, my class is going to be called next, and they will be calling me. That is what I was
Yeah.
expecting for 15 minutes. Various classes, one by one, they were calling, and when my class came, and I was very curious, ready to stand up and go and get the prize. When I was about to get up, they called another name. Simple. I did spoofing. Because it's a big crowd, no one knows who is who. When the name called Jayaseelan called, I just said, I am Jayaseelan. See the coincidence. Both names starts with
Yeah.
Jaya. Jayachandran and Jayaseelan. I spoofed. I took it and then I went and mingled in the crowd and he was trying to find me. He couldn't
Okay.
succeed. I got the prize. I spoofed because I was hurt.
Okay.
I did not expect the teacher would have done that. I was very silent. I was a little bit reserved type. I was silent and I was answering all the questions. And then, because I was silent and not more interactive, she gave to someone who was always sitting close and chatting with her. This is
All right.
not good. It's injustice. So I spoofed and I got the prize. I brought it home. So the one who distributed the prize thought I am Jay Seelan, which means I have spoofed successfully. Okay, so let us now see. DHCP spoofing attack. Same like what happened in my childhood. Here also the similar thing happens. You see, the client only first of all initiate asking for DHCP server. No DHCP server will come in search of client to provide an IP address. It is always the client which sends a discover packet as a layer 2 broadcast. And this client is there on the top right, and this DHCP legitimate server is down there, the left. The client is sending a layer 2 broadcast. Hello DHCP server, I need your help. Client really do not know where is DHCP server, that's why it is sending it as a broadcast. Because it is a broadcast, that broadcast come this way and it was sent to all ports, including this. And this came here, and this switch again it will broadcast to all ports, and it went even to the rogue DHCP server. So before the legitimate server responds to the discover packet sent by client, before the legitimate server provides an offer, the rogue DHCP provides an offer. What is that offer? Offer is not offering an IP address. Here it is saying, see, if you will accept me, this is what my address to you. That is why it is called as offer. See, this address that DHCP server is giving is not going to be immediately taken by the client. Just DHCP servers, they show their interest saying, okay, if you want my help, this is what my address that I'll be giving you. Is that okay? So it is just, giving an option. And there is another option coming from the legitimate server, another offer. This legitimate server also says, okay, if you are taking me as a server, this will be my address. Now, what the client will do, client will see which offer came first. That is what going to be a preferred one, preferred DHCP server. Because the rogue came first. To rogue only, the DHCP server will send a request. We call this a request. And as an acknowledgement, rogue is going to say address granted. So the legitimate DHCP server is not getting a chance to serve because the client did not pick it. Client gave option to the rogue. How to prevent this? Very simple. Go and enable DHCP snooping on all the devices. Snooping is opposite of spoofing. Snooping. We enable DHCP snooping on all the device and we will put only the trust on this ports. Trust, 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 trust. All other ports are going to be by default untrusted. Listen, whenever you enable DHCP snooping, every port will go to untrusted mode. Untrusted, this is also untrusted. Untrusted port can only receive a request and the discover. Untrusted port, this is also an untrusted port because I enabled DHCP snooping there. Every port in the switch is an untrusted, which means the switch is not worthy to provide an offer or an acknowledgement. If it tries to send an offer, the port will go to inconsistency state. Means it will not be used. It will go inactive. All untrusted ports can only send a discover packet and the request packet. As a client, they can work. Only the trusted ports are allowed to provide offer. Only wherever I put T, the offer can get in. Acknowledgement can also get in. This stops. This prevents rogue DHCP providing an address. Any question?
No, sir. It's clear.
What is wrong in rogue DHCP providing an address? Rogue DHCP, when he provides address, he not only provides an IP address, he also provides the mask, he also provides the gateway. That's the dangerous one. He provides the gateway, and the gateway happens to be the attacker's network. So all our traffic will be passing through the attacker, which we may not know because we are going online. We may not be focusing on how it is going, where which it is going. So it is good to make the ports untrusted by enabling snooping in the global mode and go only to those trunk ports and the legitimate DHCP server connected port and make it as a trusted. So on all the path, the way you need to configure trust, 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 right? And the other paths do not, even you can have trust here. But because this is untrusted here, right here itself it is blocked. When it tries to provide an offer, it is trying to take the role of a server. Then immediately switch will say, you cannot be a server, my friend. I discard you. I put you in inconsistency state, meaning you are no more a port which can send or receive any traffic. Attacker activates DHCP server on VLAN. Attacker replies to valid DHCP request. Attacker assigns an IP address configuration. This we already learned. This is called man in the middle attack. DHCP snooping is the solution. We make all the ports trusted in the path except the host ports. Host ports are all untrusted. This is also trusted. All these are trusted ports. DHCP snooping allows the configuration of the port as trusted or untrusted. Untrusted ports cannot process DHCP replies. What are replies? Offer is a DHCP reply. Acknowledgement is a reply. Configuring DHCP snooping on the uplink to the DHCP server. Do not configure DHCP snooping on the client ports, meaning don't make it as trusted. This is the command that we need to type, and this command is an optional command. We don't need to do it in the newer versions. The older versions need it. IPDHCP snooping enables snooping globally, and you go to the interface, whichever you trust, make it as trust. All the other things are optional, and this is very important command. For which VLAN you are enabling this DHCP snooping? IPDHCP snooping VLAN 100, something like that. The show command is show IPDHCP snooping. It shows what all interfaces are trusted, what all not trusted. A rate limit is not necessary. By default, it is 20 packets per second. Okay, so that's about DHCP snooping. Any question on DHCP snooping?
No, sir, it's
So
clear.
when there is a rogue DHCP, the switch will not allow the rogue DHCP to provide an offer
IP.
or an acknowledgement. As a result, the client will never get misguided, will always only receive from the genuine, legitimate. Next one is the source guard. DHCP snooping, IP source guard, and the next topic ARP inspection, dynamic ARP inspection, DAI. They're all interconnected. For that, the very first thing is you need to have DHCP snooping enabled in order to have the other two. In order to have the other two, you need to have DHCP snooping. Now, when you enable DHCP snooping, the switches in the middle, they are listening to what you're requesting and what you're getting. All the switch in the middle knows what MAC address you have sent the request to the DHCP discover packet, and to that MAC address what IP address was given by the legitimate server. Switches knows everything. Switches are listening to every conversation, and switches are also built a database saying For MAC address AAA, this guy AAA, he gave IP address 10.0.0.1. So the switch knows that AAA has received 10.0.0.1. Switch knows this very well. So if someone spoofs the ARP, switch will say, hey, you are a liar. Switch will clearly find that you are not 10.0.0.1. Let's say this guy says, I am 10.0.0.1, but actual 10.0.0.1 is here. When there is an ARP request, who is 10.0.0.1? This guy says, I am 10.0.0.1 and my MAC address is BBB. Then the switch will say, no, it's a lie. It's AAA is supposed to be the owner of 10.0.0. So what I'm trying to say is DSCP snooping uses DSCP snooping table. But if you see here, this guy is a legitimate server. He is not going to use any another DSCP server for IP address. Here what we do, we give IP address manually on this server. Of course, the servers will be configured with an IP address manually, isn't it? Only the
Yeah.
clients receive IP address from the server. So the switches in the middle, they don't know the MAC address and the IP address mapping of the server. In all these switches, you will have the information about all the clients and their IP address and MAC address. But there won't be any entry for the server's IP address and MAC address. Then if ARP inspection need to be enabled, then this will become untrusted. So we need to update the table manually with the IP address and the MAC address of the legitimate server, because the legitimate server did not use the DSCP service. For that, we need this source guard command. All right, after we update the table with proper MAC address and IP address of all the devices, first, you no need to update for the DSCP clients. DSCP snooping table will help you. But for those devices where there is no entry in the table, we have to provide the entries, and then we need to enable this command if you want to see whether the source address IP address matches with who they say they are. Oh, I think it's going beyond the limit. Let's see. Source guard. Let's read what it is. IP source guard is configured on untrusted L2 interfaces. Why? I want to see whether he is telling the truth, whether he is telling what he is really. As I said earlier, we need to have DSCP snooping to check this, because when you enable DSCP snooping, switches know what IP address is given to which MAC address and where they are connected. After doing that, you go under the interface and put this command. This is what called as IP source guard. IP verify source for VLAN, DSCP snooping, port security. So if anyone tells spoofed address, if they spoof any address, either MAC address or IP address, this can easily find out. Again, this is also not that much in use, but this is an option to find whether the source is genuine or not. ARP inspection is also a similar pattern. For example, you see there's an ARP request sent asking who is 10.1.1. This is the original 10.1.1, but before this guy responds, this B says, I am 10.1.1.1, and he puts his own MAC address. If I would have enabled ARP inspection with the DSCP snooping, switch will say, no, you are not 10.1.1.1. BBB is 10.1.1.3. You are telling lies, so this port will go to inconsistency state. This attacker wants to play in the middle, like he wants to tell EA that he is 10.1.1.1. He wants to tell C that he is 10112. So that whatever A send to C, it will go to B, and whatever C send to A, it will go to B, and it can do crisscross. To avoid such attack, all that we need to do is we need to enable DHCP snooping first and then enable DHCP ARP inspection. And ARP inspection, if you make this port as a trusted port, it won't verify the source because we don't have entry for this in the spoofing table. Make it as a trust so that it will bypass all the dynamic ARP inspection. It won't validate. All the untrusted port, if someone is saying, I am 10.0.0, it will say, wait a minute, let me check. Okay, yes, you're right. You can go now. It will do such verification before allowing any ARP reply or so on. All right, so the configuration is IP ARP inspection for VLAN. And then for the port where you do not want the inspection, you can say, I trust this port, no need to validate. So if the IP errors are valid, it will allow. If it is invalid, it will drop. You can also manually bind IP ARP inspection validate. If this is the source mechanism, this is the destination mechanism, this is the IP, then you permit. If anything else, you drop. So this is statically configured. Again, this is an optional one. If you have a DSCP snooping table, this is more than enough. All right. So this chapter was about spoofing attack. I think I will do this one more time in our next class with the lab. Then you will have a connection between these things. You will see how this works. Concept wise, is there any question? Forget about configuration. Do you have any question on the concepts? DSP snooping, IP source guard, and dynamic ARP inspection.
No, sir, it's clear, the concepts here.
All right. All right, next is about the attacks based on the STP's vulnerability. Using STP is good. Okay, STP is good, but STP has got some vulnerability. Shall we do this in the next class?